Okay, so this is the review for test number 2. So the first 3 questions, it says to factor completely. So the first one is 15s minus 60s to the third power. So we have 15s. I'll try to make sure my s's don't look like 5s. So hold on here. 15s minus 60s to the third power. So remember, the first thing we always look for is GCF, and there is a GCF, and the GCF is 15s. So then I get 1 minus 4s squared. So now I look inside the parentheses, and I notice inside the parentheses I can factor that again. That is the difference of 2 perfect squares. It's dots. So I bring down the GCF, 15s, 2 parentheses for dots. One is a plus, one's a minus. To figure out what goes inside, you do the square root of these. The square root of 1 is 1. The square root of 4 is 2. And the square root of s squared is s. So my answer is 15s times 1 plus 2s times 1 minus 2s. All right, so let's take a look at number 2. So I noticed with number 2 that it is 4 terms. Now remember, just because it's 4 terms doesn't automatically mean right away that it'll be grouping. Remember, always look for a GCF first. So we have 5x to the 4th minus 35x to the 3rd minus 45x squared plus 315x. So I notice there is a GCF, and that GCF is 5x. So I'm going to factor out the 5x, and then I'm left with x to the 3rd minus 7x squared minus 9x plus 63. Okay, so now that I factored out the GCF, now I'm going to do grouping. So I'm going to have the red group here, and I'm going to have the green group here. All right, so in the red group here, there's a GCF, and that GCF is x squared times x minus 7. In the green group, my GCF is negative 9, right? There's that negative, so I bring that down. And then I get x minus 7. So my factors so far are x squared minus 9 and x minus 7. And don't forget, we still have this guy here, 5x. All right, look inside the parentheses. So I notice right here, that's the difference of 2 perfect squares. So that's x plus 3 and x minus 3. Bring down the GCF and bring down the x minus 7. Now it's factored completely. All right, let's take a look at number 3. So we have number 3 is x to the 9th, y to the 9th. So I notice that it's only 2 terms. It is not the difference of 2 perfect squares because x to the 9th and y to the 9th are not perfect squares. Remember, they have to have even exponents. So is it perfect cubes? Yes, it's perfect cubes. Y to the 9th and x to the 9th are both perfect cubes. All right, so remember our SOAP, right? Same, opposite, always positive. So I'm going to have, just going to fill in the formula right now. Same sign, opposite sign, always positive. Remember, the front and the end of the first little parentheses is a and b to the first power. Second parentheses is a squared to start off. Sorry, I messed that up. All right, so we have a squared and b squared at the end. And in the middle is a times b. All right, so now we need to get our a and our b. So we want a is the cube root of the first term, x to the 9th. So the cube root of x to the 9th is x to the 3rd. Remember, you take the exponent, 9, and divide by the index, which is 3. B is the cube root of y to the 9th, which would be y to the third. So I'm just going to fill in. All right, so I have x to the third is my a minus my b, which is y to the third, times. So we have to square the a. So we have x to the third squared plus a times b, so that's x to the third times y to the third, plus b squared, so it's y to the third squared. So I'm just going to clean this up. X to the third minus y to the third times. Remember, when we have a power to a power, multiply the power, so that's x to the 6 plus x to the third y to the third plus y to the 6th power. Now I notice here, this is perfect cubes again, so you have to factor that again. So it's going to be the same formula since it's minus. Same sign, opposite sign, always positive. So we have a is the cube root of x to the third, which is x, and b is the cube root of y to the third, which is y. So it's going to be x minus y, x squared, because you square the a times b, which is xy, and the last term, which is y squared. Now you have to remember, we do have this that we didn't do anything with. This, what I just did in green, is this factored. So now I just have to write the whole thing. X minus y, x squared plus xy plus y squared, and then I have this guy here. So it's x to the 6 plus x cubed y cubed plus y to the 6th power. Okay, so let's take a look at number 4. So number 4 is the nature of the root. So remember, where nature of the roots means what kind of roots do I have? Do I have real, rational, equal? These are your choices. They could be real. The only time they're not real is when it's imaginary. Real, rational, equal, real, rational, unequal, real, irrational, unequal, imaginary. Okay, those are your 4 choices. All right, so remember, we want to do the discriminant. The discriminant is what's under the square root symbol from the quadratic formula, which is b squared minus 4ac. All right, so let's take a look at 4. A is 1, b is negative 3, and c is negative 2. So we're going to plug it in. So I have negative 3 squared. Notice I use parentheses. Minus 4 times 1 times negative 2. Just plug that in the calculator all at one time. Right? We're not going to do piece by piece. And we get 17. So now you want to think about it. All right, you have the square root of 17. Are they real? Yes. The only time they're not real is if it's imaginary. And you should remember, when we get imaginary, you have to have that negative under the square root. The square root of 17, is that rational or irrational? Can you take the square root of 17? No. So therefore, it's irrational. And it's going to be unequal. Right? Irrational is always going to be unequal. Okay. So let's take a look at number 5. Okay, so number 5, we're going to identify what the A, B, and the C are. So number 5A. Oh, actually I can't, because notice this is not in the right form. So I have to put it in the right form first. So let me rewrite it. So when I rewrite this, we're going to get 5x squared minus 2x equals negative 1. I have to get it to equal 0, so I have to add the 1 over. So it's 5x squared minus 2x plus 1 equals 0. All right, the A is 5, B is negative 2, C is equal to 1. So we're going to plug it into the formula. Negative 2 squared minus 4 times 5 times 1. So plug that in the calculator all at one time. The discriminant is negative 16. So think about that. When I have the square root of negative 16, remember, it's coming from the quadratic formula. This is imaginary. When you get a negative under the square root, it's imaginary. Imaginary roots. Okay, so let's take a look at the next one, which is number 6. Okay, so number 6 is x squared plus 9 equals 6x. So again, that's not in the right form, so we have to minus 6x over. All right, so we're going to identify A, which is 1, B, which is negative 6, and C, which is equal to 9. Okay, so now we are going to find the discriminant, which is B squared minus 4AC. So it's negative 6 squared minus 4 times 1 times 9. Plug that in the calculator and you get 0. So think about this. You have the square root of 0. Are they real? Yes. Rational? Yes, because you could take the square root of 0. The square root of 0 is 0, so that's rational. And they are going to be equal because you're adding. So think about the quadratic formula. It's plus minus in here, right? You have a number plus 0 and a number minus 0. You're going to get the same exact number. So they're real, rational, and equal. Okay, next one. We have, so number 7. Okay, so number 7 is x squared minus 4x plus 4 equals 25. So we have to minus the 25 over. X squared minus 4x minus 21 equals 0. A is 1. B is negative 4. C is negative 21. So we have negative 4 squared minus 4 times 1 times negative 21. Plug that into the calculator all at once, and we get 100. All right, so you want to think about this. We have a number plus minus our discriminant of the square root of 100 over some number, right? So my discriminant is 100. So this will be real. They will be rational because we could take the square root of 100, right? The square root of 100 is 10, right? So that's rational. Now think of it. We're going to be adding and subtracting 10. Some number plus 10, some number minus 10. That's going to give us two different numbers, so that will be unequal. Okay, so let's take a look at number 8. Okay, so for number 8, it says, given the equation 2x squared plus 4x plus m equals 0, determine the value or values of m that will make the roots of the equation, quadratic equation. And right now we're talking about real, rational, equal. Real, rational, equal. So remember, in order to be real, rational, equal, your number underneath the square root has to be 0 because you want to add and subtract 0. So that means your discriminant, b squared minus 4ac, has to be equal to 0. All right, so b is 4, so it's 4 squared minus 4 times a is 2, c is m. So this is 16 minus 8m equals 0. I'm going to add 8m, 16 equals 8m. Divide by 8 on both sides. M is equal to 2. All right, let's take a look at number 9. So now what I want is I want imaginary roots. So remember, in order to have imaginary roots, the number that's underneath the square root symbol has to be some type of negative number. Doesn't matter what negative number it is, just any type of negative number. Has to be a negative here. So that would mean the discriminant, b squared minus 4ac, to represent a negative number, it has to be less than 0, because every number less than 0 is negative. So we have 4 squared minus 4 times 2 times m has to be less than 0. So we get 16 minus 8m is less than 0. So minus 16 from both sides. Negative 8m is less than negative 16. Divide by negative 8. Now remember, when you divide by a negative number, you have to flip the sign. So m is greater than 2. So any number greater than 2, if you use that for m, will make the roots imaginary. All right, let's take a look at 10. Same thing, going to be doing the same thing, but now I'm going to use a different equation to practice. Given the equation 3x squared minus 6x plus m equals 0, determine the value or values of m that will make the roots of the quadratic equation. We're looking for real rational equal. So remember, real rational equal, your discriminant, b squared minus 4ac, that has to be equal to 0. So we have negative 6 squared minus 4 times 3 times m equals 0. So I have 36 minus 12m equals 0. Add the 12m to both sides. So 36 equals 12m. Divide by 12, m is equal to 3. All right, next, I want my roots to be imaginary. So remember, what's underneath the square root symbol, b squared minus 4ac, in order for it to be imaginary, it has to be a negative number, so it has to be less than 0. So we have negative 6 squared minus 4 times 3 times m is less than 0. So 36 minus 12m is less than 0. So this time I'll add the 12m to both sides. So 36 is less than 12m. This way I don't have to flip the sign. Divide by 12. M has to be greater than 3. All right, let's take a look at number 12. Okay, so number 12 says, explain how you would distinguish if the roots are real, rational, unequal, real, irrational, unequal. Okay, so in order for them to be real, rational, and unequal, in order for it to be rational, you have to have a perfect square. It has to be greater than 0 under the radical, and it has to be a perfect square. But it can't be 0, because if it's 0, then it's equal. So it has to be, so the discriminant, remember that's the number under the radical, must be greater than 0, right? Because then that means it's a positive number. And it has to be a perfect square. So, and a perfect square. Because you want to be able to take the square root of it. Because if you could take the square root of a number, it's a rational number. You're going to get a nice whole number. All right, now in order for it to be irrational unequal, discriminant, again, has to be greater than 0 because it has to be positive. Because remember, if it's negative, it's imaginary. So it has to be greater than 0. That means it's positive. Now, in order for it to be irrational, it can't be a perfect square. So at end, it has to be a non-perfect square. So meaning like it has to be like 7, 10, 13, something like that. Okay, so let's flip it over and we'll take a look at the rest of the practice problems. Okay, so number 13 says determine the roots. So we're solving the quadratics in simplest radical or a plus bi form. So we have to just make sure that we go with the answer as far as we can with the radicals or any negatives that are there. All right, so let's take a look at number 1. I have 3x squared plus 2x minus 3 equals 0. So the first thing I want to check to see if it's factorable. When I multiply first times the last master product, I get negative 9. There are no numbers that multiply to 9 minus to 2. So I have to now decide, do I use quadratic formula or complete the square? Now, in order to complete the square, we'd have to divide by 3. Now, this is going to be a disaster in the middle because it's going to give me fractions. So I want to use quadratic formula. Quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. Okay, so let's see. It's in the right form, so that means a is 3, b is 2, c is negative 3. All right, let's plug it in. So we have x equals negative whatever b is positive 2, so it's going to be negative 2, plus minus 2 squared minus 4 times 3 times negative 3 over 2 times 3. So I have negative 2 plus minus, plug in what's under the square root, only under the square root, and when you plug in what's under the square root, we get 40. So now we want to simplify the square root of 40. That is 4 and 10, which is 2 the square root of 10. So then I have x equals negative 2 plus minus 2 the square root of 10 over 6. Now we want to make the heart. Everything reduces by 2. This becomes negative 1. Watch the sign. 1 and 3. So x equals negative 1 plus minus the square root of 10. I don't need that 1 in front over 3. All right, let's take a look at number 14. All right, so number 14, which is x plus 1 squared plus 64 equals 0. Now, when I see that, I realize that this here is kind of like the start of complete the square. This number just happens to be on the wrong side. So let's move that number over. So when I move that constant over, now I have x plus 1 squared equals negative 64. So I can solve it right from here. To get rid of the square, you square root both sides. Remember, a square and a square root cancel each other out, so now I'm left with x plus 1 equals. The negative under the square root becomes an I. The square root of 64 is 8. Now remember, we're square rooting, so it's plus minus. Minus 1 from both sides, that goes in front of the plus minus, so it's x equals negative 1 plus minus 8i. That's simplest a plus bi form, which is what it says here. I just happen to have 2 answers. Okay, so next we'll do is number 15. So when I look at number 15, I notice that I have these parentheses here. So I need to get rid of them. It has to be equal to 0. So let's do that. I have x squared minus 3 equals 3x plus 9. So I want it to be equal to 0, so I'm going to move everything over to the left. X squared minus 3x plus minus 9 equals 0. All right, so now this is not factorable. If it was, I would factor it, but it's not. So I'm going to use the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac over 2a. A is 1, b is negative 3, c is negative 9. So I want negative whatever b is negative 3 here, so that's going to make that positive 3. So we have negative 3 squared minus 4 times a, which is 1, times c, which is negative 9, over 2 times 1. Again, plug in what's under the square root. So we have 3 plus minus. When I plug in what's underneath the square root symbol, we get 45 all over 2. So now I want to simplify the square root of 45. So what perfect square goes into 45? That would be 9 times 5. And the square root of 9 is 3. So it's 3 the square root of 5. So then I have here x equals 3 plus minus 3, the square root of 5, all over 2. All right, so the next thing you would want to do is to see if you can reduce this. See if you can make the heart. We can't make the heart. There's nothing that goes into 3, 2, and 3. So my final answer is x equals 3 plus minus 3, the square root of 5, all over 2. Okay, so let's take a look at number 16. Okay, so number 16 is x squared minus 14x plus 37 equals 0. All right, so I'm looking at this and I notice that the leading coefficient is a 1. I notice my middle term is even. So I'm going to complete the square for this one. So I minus 37 first. Remember, you have to have a leading coefficient of a 1 and you have to move the constant over to the other side. So that is a 3 there. All right, so now we're ready to complete the square. So now I do half of the middle number, half of b. So it's half of negative 14 is negative 7. Square it is 49. Add that number to both sides. So we have negative 37 plus 49. And negative 37 plus 49 is 12. The left side I'm going to factor. Remember, we get the same parentheses when we factor. We get x and x. And inside the parentheses, remember, it's the number that we squared, which is negative 7. Another way to write x minus 7 times x minus 7 is x minus 7 squared equals 12. To get rid of the square, we square root both sides. So I have x minus 7 equals plus minus the square root of 12. Now we want to simplify the square root of 12. So what perfect square goes into 12? That would be 4 times 3, so it's 2 square root of 3. So x minus 7 equals plus minus 2 the square root of 3. Add the 7 over. Put that in front of the plus minus. X equals 7 plus minus 2 the square root of 3. Okay, so let's take a look at number 17. Okay, so number 17, I noticed that we have parentheses here, so I want to distribute and simplify first. So we have x times x is x squared. X times 5 is 5x. Negative 6 times x is negative 6x, and negative 6 times 5 is negative 30. So I'm going to clean up the middle. So we have x squared. Negative 5x minus 6x is negative 1x minus 30 equals 12. Now I do want to move the 12 over to the left, so minus 12. X squared minus x, negative 30 minus 12 is negative 42. All right, so this is actually factorable, so I'm going to factor. So I multiply the first times the last, we get negative 42x squared. So what multiplies to 42 minuses to a 1, because there's a 1 in front of this x. That would be negative 7x plus 6x, right? So negative 7 times positive 6 is negative 42, and negative 7 plus 6 is negative 1. Bring down the ends. Now we'll factor by grouping. Group the first two, group the last two. The GCF of the first group is x, and then we have x minus 7. The GCF of the second group is positive 6 times x minus 7. So my factors are x plus 6 and x minus 7 equals 0. And then you make your t-chart and finish it up. So on the left here, I get x equals negative 6, and x is equal to positive 7. All right, let's take a look at number 18. Okay, so for number 18, you're going to use I part. So you're going to type in I part, I to the 32. I to the 32 is 1. To plug this in, you're going to do 3 first, and then I part. And then type in I squared. But you should know, I told you I squared is one of the ones you're supposed to know. I squared is negative 1. So this is plus a negative 3 minus. Now you're going to plug in 4i to the 4 and then I part 52. You get 4 plus. Now type in I part I to the 5th, which is I, minus. Now type in I part I to the 11th, that's negative I. All right, so we have 4 minus 3. 1 minus 3 is negative 2. Minus 4 is negative 6. I minus negative I, that's plus plus, so that's plus 2I, because I plus I is 2I. All right, let's take a look at number 19. So remember, in order to add or subtract radicals, square roots, you have to have the same radicand. You have to have the same number underneath the radical. So we are dealing with square roots. I noticed the negatives underneath, so they're going to become I. So I have I the square root of 50, I the square root of 128. So the perfect square that goes into 50 is 25 times 2. The square root of 25 is 5, so it's 5i, the square root of 2. The perfect square that goes into 128 is 64, and that's times 2, which makes sense because I want to be able to add them. And remember, these have to be the same. The square root of 64 is 8, so it's 8i, the square root of 2. So we have 5i minus 8i is negative 3i, and then the square root of 2. Because you keep the radical the same, you just add or subtract the coefficients. Those are what's in front. Okay, so let's take a look at number 20. All right, so remember this symbol here means inverse, and inverse means to switch x and y. So I'm going to first start off by writing it as x equals. So it's y equals x to the 4th power plus 3 over 2. So I want inverse. Inverse means to switch x and y. So I get x equals y to the 4th plus 3 over 2. All right, so what I'm going to do to make it easy, I'm going to put the x over 1 and cross multiply. So 2 times x is 2x equals y to the 4th plus 3. I'm going to minus 3 over, so 2x minus 3 equals y to the 4th. To get rid of a 4th power, you're going to go into 4th root both sides. Just like to get rid of a square root, you would square both sides. You 4th root it. So they cancel each other out. You're left with y equals the 4th root of 2x minus 3. And just make sure you write it with the correct notation. The inverse of f of x is the 4th root of 2x minus 3. And that's a 4 inside there. Okay, so let's take a look at number 21. Okay, so number 21, we have the width of a rectangle is x minus 6, and the length is x plus 7. So let's draw a picture. So I have a rectangle. The width is x minus 6, and the length is x plus 7. Part A says, represent the perimeter as a polynomial. So now remember, perimeter means to add all the sides. Okay, remember, opposite sides in a parallelogram or a rectangle are equal. So it's going to be x plus 7 plus x plus 7, because that's the opposite side, plus x minus 6 plus x minus 6. Combine like terms, x plus x plus x plus x is 4x. 7 plus 7 is 14. Then we're going to minus 6, and minus 6 is 2. That's the first part. Part B says, if the perimeter is 66, so that means if this is my perimeter, 4x plus 2, and that perimeter has to equal 66, right? So I set it equal to 66. What are the dimensions? All right, so we minus 2, 4x equals 64. Divide both sides by 4. So we get x equals 16. Now I can find the dimensions. So my length, which is x plus 7, is going to be 16 plus 7, which is 23. And the width, which is x minus 6, that's 16 minus 6 is 10. All right, so let's take a look at C. So it says, if the length is decreased by 1, so I'm going to redraw my picture. Sorry, I just need more room. All right, so we had the width was x minus 6, and we had the length was x plus 7. So now it says, if the length is decreased by 1, so I'm going to minus 1 from the length, and the width is increased by 2, so I'm going to add 2 here. Right, so now this is my rectangle. This is my new rectangle. So this is x minus 4 and x plus 6. It says, represent the area of the polynomial. So remember, area is length times width. So my area is x plus 6 times x minus 4. All right, so we're going to double distribute. So x times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x. And 6 times negative 4 is negative 24. So we'll clean it up. Area is equal to x squared plus 2x minus 24. All right, that was C. Now it says find the dimensions if the area is 39. Now remember, this is my area. So my area is equal to 39. So x squared plus 2x minus 24, your area has to equal 39. All right, so what I'm going to do is complete the square because I noticed that the number in front of my x squared is a 1 and my middle term is even. So I'm going to add 24 to get it in the right form and then start completing the square. So 39 plus 24 is 63. So now I'm going to do half of 2, which is 1. Square it is 1. Add that to both sides. So we get x squared plus 2x plus 1 equals 63 plus 1. So 63 plus 1 is 64. I'm going to factor the left side. So we get x and x. And remember, what goes inside the parentheses is the number that we squared. So we squared a 1, so it's going to be positive 1, positive 1. So this is x plus 1 squared equals 64. To get rid of the square, you're going to square root both sides. So we get x plus 1 equals positive and negative 8. Minus 1 over, we get x equals negative 1 plus minus 8. So now we do want to separate this. So we have x equals negative 1 plus 8, so x equals 7 here. X equals negative 1 minus 8, which is negative 9. Now, you don't want to reject that negative, even though we're talking about length, because when I plug it in, I might actually get a positive length. So you actually have to check both. So let's go back up here. I'm going to start with 7 first. So if my width is equal to x minus 4, so if I have 7 minus 4, that's equal to 3. And my length is x plus 6, so that's 7 plus 6 equals 13. So these are both good. Now we're going to try negative 9. If I plug in negative 9 for x, for the width, I get negative 9 minus 4, that's negative 13. We can't have a negative answer, a negative length. So then you would make sure that you cross this off, because x can't be negative 9. Okay, so that's it. Happy studying, and I'll see you guys tomorrow. Have a good night.